Okay, so again, 12.1 is called the Introduction into Conics section. So we're going to talk about what the conics are. You'll get an idea of what they look like, and we're going to explore them a little bit using the graphing calculator today. And then there's a section, an individual section on each one of the conics that you will then learn how to graph each individual one without using a graphing calculator. And you'll learn more about each individual one throughout the So what are conics? Conic sections are formed by the intersection of a double right cone and a plane. So if you could picture a cone, two cones flipped upon each other and joined at the point, that's kind of what these look like. Then there's four types of conics that can be formed. If I took a horizontal plane and I slid it into the cone while it's held horizontally, flat, then I form a circle. If you turn it on its side a little bit and still slide it all the way through, you get an ellipse, which is like an oval. If you slide it at an angle in which it goes through the side and into the top like this, you get almost that bowl shape, which is like your parabola. And if you slide it vertically through the two cones, you get, it's almost like a double parabola, one facing either direction, and that's called a hyperbola. So we're going to talk about each of these individual four conics over the next couple of sections, but just so you know what they are: circle, ellipse, hyperbola, and parabola. So a circle versus an ellipse. A circle is defined by its center and its radius. An ellipse is an elongated shape similar to a circle, and it has two perpendicular axes of different lengths. So where a circle is obviously the same distance all the way around from your center, I have my point in the middle, this is the center, all of the lines that go from the center to the edges, or the radius, are all the same length. Ellipse, which I actually don't even know if there is, if I can do a oval. An ellipse is more like that. So you can have a vertical ellipse, or you can have a horizontal ellipse. You can have one like this, or you can have one like this, okay? But they're more oval shaped. What this says about those is that they have two perpendicular axes. So one's going to run horizontal, one's going to be vertical. And where they meet's a right angle. And vertical and horizontal, and they meet at a right angle. So they don't have radii because they're not all the same length, okay? But you have two axes, a vertical one and a horizontal one. One's called a major, the major is the big one, major and minor. All right, so we're going to start by graphing these so you can get an idea of what they look like, okay? And we're going to use the graphing calculator today. Again, eventually when we get into the next section, we're going to learn how to graph them by hand, because I actually think it's easier to do it by hand than it is having to solve the equation. So if you go to your graphing calculators and you go to graph something, what button do you normally hit to type in the equation? How do you go to type in the equation? What window do you have to be on? There's a little button that says y equals, right? And that's where you normally type in your equation. You with me? So can I type it in the way that it looks? Is that set equal to y? No. So here's the fun, right? This is where the adding and subtracting comes into play. You have to solve this equation for y first, okay? So if I wanted to get y on the side by itself, what's one thing I could start with? Not yet, because in order to do that, you only want one square root on either side. So we want to work the other way. That's going to make it more complex. Go ahead. So I'm going to send the x squared minus 1 to the other side. So I would subtract x squared minus 1 from both sides. Or x minus 1 squared, sorry. So it's gone from here. I have y minus 1 squared equals 1 minus x minus 1 squared. Now, how do I get rid of the squared on the parentheses of the y? Don't distribute because you don't want to expand it. You don't want to have two y's. You want to limit your y's to just one. Square root. Good. What happens when I square root? What do you have to remember? If this was x squared equals 16 and you go to square root both sides, what do you got to remember to do?
Plus or minus.
Good. So this is plus or minus the square root of 1 minus x minus 1 squared. So I get y minus 1 equals plus and minus the square root of 1 minus x minus 1 squared. And then the last step to get y by itself would be number 1. So y equals plus and minus the square root of 1 minus x minus 1 squared plus 1. So that means there are two equations here, one in which the square root is positive and one in which the square root is negative. So this is really y equals a positive square root of 1 minus x minus 1 squared plus 1, and that plus 1 should be outside the radical, and y equals negative square root 1 minus x minus 1 squared plus 1. Now I've got it where it's y equals, right? So I can enter, and I have to enter in both of these equations, okay? So I'm going to type them both into my graphing calculator. All right, so when I graph my result, I got this, right? That is actually two of those arcs being graphed. Technically, they're two parabolas, right? One parabola opening upward, one parabola opening downward, which should make sense for you guys. Like if I have a squared, x squared, then you should know it's parabola. If it's positive, it opens up. If it's negative, it opens down. And it's meeting at that point in the middle there, which forms the, what shape is this? Nope, an ellipse. Good. If it's like that oval shape, a circle would be perfectly round. So if it's an oval like this, then it's an ellipse. All right, so we graphed it, we pulled it in, okay, and again, we identified that this would have been a circle, okay. The center, which is here, this is a 1, so the center would be at 1, 1, and then there's intercepts here at 1, 0, and here at 0, 1. So two things, well, three things you really need to get from this section is, one, how to solve for y, if you ever had to type it into your graphing calculator, because most do not have another option. Two, is learning how to identify the type of graph it is, which now we know this is a circle. 3, identifying things from your graph, like your centers, your intercepts, that kind of stuff. So they're going to ask you different things based on different conics, what it is. For a circle and a ellipse, they're going to ask you for center, and they're going to ask you for your intercepts. Yep.
Is the graph on the board the positive one or the negative one?
That's both. So this is your negative, and this is your positive. We want them to blend together.
How do you get it to like that?
If you're typing both in at the same time, so it's graphing both on the same axis. You just have to have them both typed in. Okay, so check your... All right, so it says, graph each equation on the graphing calculator, identify each conic section, and describe the center and intercepts. So again, what's the first step we have to do? Isolate the y. This one's a little bit easier to start, right? How do I start to isolate that y? Good. So 25y squared would equal 100 minus 45x squared. Then what? Divide by 20. You could square root or divide, doesn't matter. So if I divide by 25, I could divide by 25. Y squared equals the 100 minus 45x squared over 25. And our calculators are smart enough to handle that, so you can actually leave that. You just got to be careful how you type that in your graphing calculator. All right, and then the last step would be to square root both sides, making sure you do the plus and minus. So I get y equals, and I'm going to have two equations. The square root of 100 minus 45x squared over 25. And y equals negative square root of 100 minus 45x squared over 25. Again, you could simplify that. I could make the bottom 5 and get it out of the denominator, okay? But you can also type the whole thing in the way that it is because your calculator can handle it. So next one. All right, so if I look at this, and this looks pretty close to a circle, the way to find out is look at what's happening from your center to the sides of this shape. So from here to here, it's 2, right? From here to here, it's 2. Is from here to here 2 the horizontal? No. So if they're not the same, then this is a what? This is an ellipse, okay? So they'd have to be the same in order for it to be a circle. So I'll open up the assignment so you can start it if you want to get a head start on it, but it won't be till Tuesday that we do a homework check on it, okay? So on this graph, the center is at 0, 0. And then you've got two x-intercepts. One here, which if this is 1, that's 1.5. So 1.5, 0. And over here, negative 1.50. Those are your x-intercepts. And then you have two y-intercepts as well. Up here at 0, 2. And down here at 0, negative 2. Okay, so we'll finish the notes for this on Monday.